So we're going to start off with what happens when we have unknowns on both sides, and that when I say unknown on both sides, it's the same unknown. So an x on the left, x on the right, not an x and a y. Okay, so the same variable. So here, the first step we want to do is isolate our x's and numbers as usual. So this is, you might think, well, this just looks like what we've been doing with one little step, and that is why I just call this multi-step, because this is the beginning. So we're going to do this part in multiple steps, and by example 3, I'm going to take a couple shortcuts. So here, let's start off by moving all the numbers over. So we know to move that 3 over, we subtract it from both sides. Okay, so this means we're going to be left with 2x equals 5x minus 9. Okay, well, now we have this 5x over on this right side, so let's subtract 5x. Now, in the case that you end up getting a negative x, we know how to do that because we've dealt with that before, so that's not a real big issue. But if you can, always choose it so you have a positive x at the end. If you notice, I'm going to be left with negative 3x is equal to negative 9. So I'm going to just bring this up here. So negative 3x is equal to negative 9. Then my last step, we know we have to divide by our coefficient, which is, negative 3, not negative 3x. So divide both sides by that negative 3, and we're going to find that our x is then equal to 3. So if you notice, multi-step, technically we kind of have one step here, 2 steps here, and 3 steps to finally solve. So we don't talk about it as a 3-step, it's just multi-step, because it kind of, there's not one standard fit all for all these questions. Okay, so looking at the next one, well, let's deal with the first thing. We see a negative 3x, let's make that a positive 3x. This time it'll work out nicely if we do. So here, right away, we can start to simplify and make it easier to see. So negative 5 on our left, right, is equal to 5x minus 10. So now we've got to move the number that's minus 10 from the right over to our left-hand side. That way we've isolated our variables from our values. Going down, as we notice, 10 and negative 5 is simply 5, and we have 5x. Now, at this point, you might be able to say, I just know that x is 1, and you could write the answer. That is completely fine to do. I would always just show the method if you can, because while I'm talking, I could write down the method, and that way I never lose any marks. So we find that x is 1. And last one. So I'm going to show you how to do this kind of in shorter steps, so we can get it back to doing a 2-step problem. So if you want, just choose a side. So I'm choosing my left side. I'm just going to do the opposite operation to that. Okay? Then I know I have to do the plus 2x over here. So now I'm looking at this right side, and I'm doing the opposite to this. Negative 3 is plus 3, and over here. So if you happen to mess up and do the both add 2x and add 6, say, to the left, you'll just wind up with one side being 0, which is, you can still solve it from there by just moving over a value after. However, if you notice, we've pretty much done this all in one step, a lot of this. So we are going to be left with, well, on the left-hand side, just negative 3. On our right-hand side, we're going to be left with negative 2x. Then we can just divide by our negative 2, divide by our negative 2, and we'll find that x is equal to 3 over 2, or 1.5.